Hello, welcome back. The title here is called Calculating Percents Using Fractions. This is part 1. I'm excited to teach you this because in this lesson you're going to learn 3 things. You're going to learn how to calculate using percentages, like what would we actually use it for. Number 2, you're going to learn how to use the fraction equivalent of a percentage to do that. And number 3, I'm going to teach you how to multiply fractions in some cases that yields a faster result without going through so much work. It's called cross cancellation. When we multiply 2 fractions, we can multiply and then get the result, but I'm going to show you a way that you can actually kind of pre-simplify ahead of time your fractions and make the work a lot easier to multiply them. So 3 really important things here. Now remember, every single percent that you'll ever see can always be represented as a fraction equivalent to that percent. And then also we talked about the decimal equivalent of a percent also. Here we're going to be calculating percentages using the fraction equivalent of a percent. And then later on we'll tackle the same concept but using the decimal equivalent of what a percent is. So for instance, what if I ask you to calculate 50% of the value 16? Maybe what I have in my hand is 16 rocks. And I did tell you that I have 16 rocks here, and I'm going to give 50% of my rocks away. What does that mean? First of all, what does 50% mean in your mind? 50% means half. That's one of your anchor points that you should always remember, because 0% means nothing, and 100% means everything. But 50% is right in the middle, and it's half of whatever it is you're talking about, right? And we've talked about that before. So if I tell you that I'm going to give away 50% of my money, or 50% of my rocks, or 50% of my milk, or if I'm going to cut 50% of my grass in the front yard, all of those things mean I'm just doing half of it. That's all it means. And when you see something like 50% of something, it means you're going to take whatever it is that you have, and you're going to cut it down using multiplication by whatever this is telling you. And we already know that 50% means 1/2. But let's go through the process pretending you didn't know that this was 1/2. What does 50% mean to you? 50% means 50 out of 100, right? And we know that this fraction we can simplify. So the first step here, we're calculating percent using fractions. We want to figure out what is the fraction equivalent of 50%. We already know the answer, but let's just go through it just all the same. We can simplify this by dividing by 50 and then dividing the bottom by 50, right? So what we figured out is that 50 divided by 50 is 1, and 100 divided by 50 is 2. And what we have figured out is that any time that we have 50% of anything, an equivalent fraction to that is 1/2. This is 1/2 and another half of a pizza. Of course, it makes a whole. Half and a half make a whole. And if you look on the other side of these guys, that 1/2 is equal to this 50%, and the other half is equal to the other 50%. So when you get more and more and more higher away from 50%, you're getting closer and closer to the entire, whatever it is you're talking about, everything. And when you go close to 0, you have nothing at all. 50% right in the middle. And we figured out that 50% is just equivalent to the fraction 1/2. So when we take 50% of 16, what we really want to do is we want to take 16, whatever it is that we're talking about, in this case it's 16, and the of basically means multiply it by whatever the percentage is, but we need to express the percentage as a fraction, which is 1/2. 1/2. Now, since we're multiplying 16, which is a whole number, times 1/2, we're going to write the 16 as 16 over 1. So in order to actually calculate the percentage of 16, we're just going to take 16 and we're going to multiply by the percentage, but we're going to represent the percent as a fraction. Basically, you never ever multiply by 50% or 30% or 16%. You always convert it to a fraction to multiply, or later on, you convert it to a decimal to multiply, and you're going to get the answer, the same answer, no matter which way you do it. But here, we're only using the fraction equivalent. So convert it to a fraction, multiply by the fraction, right? Now in this case, multiply. 16 times 1 is 16, and 1 times 2 is 2. Because we multiply fractions, we multiply the tops and we multiply the bottoms. Now 16 divided by 2 is 8, and that's the final answer. So if I tell somebody, I'm going to give away 50% of my 16 rocks, then that means I'm giving away 8 of my rocks. If I have $16 in the bank and I'm giving away 50% to my friend, then I'm giving away $8 because 50% means half. That's what it means. The reason it means a half is because 50 out of 100 simplifies to 1/2. And then when you multiply, the of means multiply, by whatever it is you're talking about, you're multiplying by the fraction 1/2, which of course cuts the thing in half to 8. Now this is the bulletproof way to do it. I want you to know that, but I also need to teach you something that to make multiplying fractions a little simpler because it will save us time later, right? So let me rewrite this fraction multiplication one more time. I'm going to kind of go down here and just rewrite it again. 16 over 1 times 1/2. Notice that we multiplied, and then when we got to this point, we divided, and then we got an 8. All right? What you need to realize is that when you're multiplying fractions, the 16 will be multiplied by the 1 over there, and then the 1 will be multiplied by the 2 over there. That's all correct. And what you do is when you multiply the fraction, you simplify the answer. You always multiply fractions and simplify the result. But you're actually allowed, when you're multiplying fractions like this, you're allowed to kind of pre-simplify what you have. So notice that you have a 16 on the top and a 2 on the bottom, and you have a 1 here and a 1 here. Remember, we talked about canceling the same thing. When you have it in the top and the bottom of a fraction, you can cancel it. So this 1 can cancel with this 1, right? So they're gone. Basically, what they're really doing is they're dividing away. 1 divided by 1 is 1. So poof, it disappears. It doesn't really do anything if you divide away to make 1. But now we have the 16 and the 2. What does that mean? I can pre-simplify. If I had 16 on the top and 2 on the bottom, notice they're both even numbers. So I can ask myself, can I pre-simplify this fraction? This is also called cross-canceling because you have cross terms here and we're going to be canceling things. So notice this is 2 and 16. I can divide this by 2 and divide by 2. Remember, anytime you simplify the fraction, like the fraction, 4/8, you're always asking yourself, can you divide the top and the bottom by the same thing? Yes, I can divide by 4, I can divide by 4, and so that becomes 1/2. I'm always asking, can I divide the top and the bottom by the same thing? Here is something on the top, and here is something on the bottom. I can ask myself, can I divide by something? Yes, 2 divided by 2 is 1. 16 divided by 2 is 8. So I'm not writing the division symbols. I'm asking myself out loud, what can I divide by? 2 divided by 2 is 1, and I have to do this, divide by the same thing on the top. Just like when I simplify fractions, I have to be dividing by the same thing. So 16 divided by 2 is 8, and 2 divided by 2 is 1. I have to pick a pair on the top and the bottom. They can be cross terms on the top and the bottom, and I can pre-simplify by dividing the top and the bottom by the same thing. Now, what does this do? The only thing left here is 8 on the top, and you have a 1 that's gone, a 1 that's gone, and there's a 1 here. So 8 divided by 1, because basically that's all that's left, is 8. And that's the answer. It's the same answer that I got before, but I did the pre-simplify. Instead of multiplying and then dividing at the end, I kind of pre-simplify everything in the beginning, right? Now, why would you want to do that? For these numbers, it doesn't matter. It's easy to do it the regular way. But when I give you fractions with larger and larger numbers, we're going to get to them in just a minute, it's going to be way faster to do this than to multiply and get these really large numbers and then simplify at the end. So for the first few problems, I'm actually going to work it a couple of different ways to get you comfortable with this, but then we'll drop the training wheels and then I'll expect you to kind of know as we move forward to do that for as many problems as you can. All right, so let's take a look at problem number 2. Let's say I would like to take 20% of 30. Maybe I have $30 in the bank and I want to give 20% of my money, of my $30, I want to give 20% of it away to my best friend to go buy some candy or whatever. Right? So the first thing is we need to multiply 30 times this percentage, but we're going to replace this with the fraction equivalent. So what is 20 over 100? That is what a percentage means. And I can simplify this, 20 over 100. I can simplify this percentage because I can divide the top by 20 and the bottom by 20. You could divide by 5 and so on, keep simplifying, but I know that I can divide by 20. 20 divided by 20 is 1, and 100 divided by 20 is 5, because 5 times 20 is 100. So the fraction 20% is the same exact thing as 1/5. So what I'm going to do in my problem is I'm going to take my $30 or whatever, and I'm going to chop it down, this percentage, which is equivalently a fraction. When I multiply it The of means multiply by 1/5. Instead of multiplying by this 20, I always multiply by the fraction equivalent, right? I multiply by the fraction equivalent, and I'm taking this and I'm cutting it down because the fraction 1/5 is less than 1. I'm chopping it down, and that's how much money I'm going to give away. Now the 30 over 1, we're going to write this 30 over 1 because we're multiplying fractions here. So on the top, 30 times 1 is 30, and on the bottom, 1 times 5 is 5. And I now divide. 30 divided by 5 is 6. So if I had $30 in my bank and I said, I'm going to give 20% of it away to charity, then that means I'm going to give $6 away. Because 20% means that for every $5 in my bank, I'm giving one away. One out of every $5 away. 20% is 20 out of every $100 I have, which is equivalent 1 out of every $5 I have. So when I multiply by that fraction, I'm actually going to give $6 away. All right? And that makes sense because if you were giving away, let's say 50% of your money, then you would cut this in half. It would be $15 you'd give away. I'm giving away way less than that, so the number I'm giving away is 6. Now what I would like to do next is show you, of course, that the fraction 1/5 here is represented by this green wedge right here. If you flip this over, that is equivalent to 20%. So I'm just kind of showing you that 20% is exactly the same thing as 1/5. And so we multiply the fraction to cut it down. And then the next thing I want to show you is how to cross simplify these things. So let me rewrite this again. 30 over 1 times 1/5. So let's forget about the ones for just a second. We know they're going to cancel. Anything on the top and bottom will always cancel, but they're ones, so they don't really matter anyway. Look at what I have here. Of course, I multiplied and then simplified here, but I have a 30 here and a 5 here. I can pre-simplify. I can divide both of these by 5. So in my mind, I say 5 divided by 5 is 1, and I write the 1 there. And also 30 divided by the same number 5 is 6. So I'm picking a pair of numbers and I'm dividing them both by the exact same thing. 5 divided by 5 is 1. 30 divided by 5 is 6. And now I have a 6 here and a 1 here, and I can then do the rest of the math because I can see that 6 times 1 is going to be 6, and then it's going to be 1 times 1 is 1, so it'll be 6 divided by 1, which will be 6. And that'll be exactly the same thing as what I got before. You can also, if you want to, strike out these ones. I mean, that's fine. You can strike them out. They're gone. 6 divided by 1 is 6. But ones don't really do very much in terms of fractions, so it isn't all that critical that you strike them out. The most important thing is to pick these numbers. If they're on the top and the bottom over here, or the top and the bottom over here, they have to be one on the top and one on the bottom, and you must be multiplying fractions in order to do this. And the reason you can do it is because if I were to multiply them, then the numbers from this number and this number are kind of combined together to give me this one, and this number are kind of combined together to give me this one. So I can simplify this. Notice I can simplify this fraction by dividing top and bottom by 5. So I can multiply first, then simplify by dividing by 5 and 5, or I can just divide by 5 and 5 to begin with before multiplying. All right, let's move right along. Let's say we're doing or taking 15% of 20. So let's say that I'm going to give away 15% of my 20 baseball cards. I have 20 baseball cards. I'm going to give 15% of them away. How many am I going to give away? Well, first thing is I need to figure out what is 15% as a fraction. It's 15 out of 100, and that one can be simplified because I can divide top and bottom by what? By 5. Right? 15 divided by 5 is 3, and 100 divided by 5 is 20. So we're saying 15% is exactly equivalent to the fraction 3/20. So then I'm going to start with my 20 baseball cards, and I'm going to chop it down by multiplying. The of means multiply by 15%, but I'm using the fraction equivalent of that because don't forget, these are the same exact thing. The 15% and the fraction are the exact same thing. The 20, of course, I'll write as 20 over 1. Now let's do it kind of the way we know how to do it already. Let's multiply this. 20 times 3, 20, 40, 60. You can count by 20s if you want. 20 times 3 is 60 on the top. And then 1 times 20 is 20 on the bottom. Right? So I could simplify this. I could divide top and bottom by 10 if I want to, or even by 20 if I want to. I can divide by 20 right here and 20 right here, or I can just, I guess let's just do it like that. Let's just do it like 60 over 20. I can divide top and bottom by 20. They're both divisible by 20. And 60 divided by 20 is what? 3. And 20 divided by 20 is 1. And so 3 divided by 1 is 3. So this is the right answer. If I have 20 baseball cards and I'm going to give 15% of them away, what I'm saying is I'm going to give 3 of them away, right? Because 15% means that for every 100 baseball cards I have, I'm giving 15 away. Or it means out of every 20 baseball cards, I'm giving 3 away. And since I had 20 to begin with, I'm giving 3 away. That's what this means, right? Now let's take a moment to calculate the answer using cross cancellation. 20 over 1 multiplied by 3 over 20. We did it the harder way first. We multiplied the tops, multiplied the bottoms, simplified, and calculated. But we notice right away that we have a 20 on the top and a 20 on the bottom. So you ask yourself, can I divide? Of course, you know they're going to cancel because they're the same number, but really what you're asking is 20 divided by 20 is 1, and this 20 divided by this 20 is 1. You pick a pair of numbers and you pre-simplify. Can I divide these numbers by something? Yes, I could divide by 10 or 5 or whatever, but I can just divide by 20 here and by 20 here, and I get a 1 and a 1. Then 1 times the 1 is remaining. 1 times 3 is 3 on the top here, and 1 times 1 is 1 on the bottom, and the answer is 3. So you see, I get to the same answer, but since I pre-simplify, I never have to do this intermediate stuff here. For these problems, again, it's not that big of a deal. But when I give you larger problems, it's going to save you a ton of time to do this, so you need to get used to seeing it. All right. Making good progress. We're really learning 2 skills here. We're learning how to deal with percents, and we're also learning how to cross-cancel terms when we multiply. Let's calculate what is 12% of the number 50. Let's say I have 50 turtles on my turtle farm, and I'm going to give 12% of them away to, a family member, whatever. How many turtles am I going to give away? Well, 12% means 12 out of every 100 turtles that I actually have is what does 12% mean? I can simplify that into a simplified fraction because I know that I can divide the top and bottom. Let me catch up here. What problem am I on? I can divide the top and bottom by 4. 12 divided by 4 is 3, and 100 divided by 4, 25. So what it means is that for every 25 turtles I have, I'm going to give 3 of them away. That's what 12% means, right? So what I will do is that I will start with the 50 turtles on my turtle farm, and I will cut them down by this fraction amount by multiplying 3 over 25. So let's first calculate, we'll do it as 50 over 1. Let's first calculate it the harder way and see what we get. 50 times 3 is 150. 50 and then 100 and then 150. And then on the bottom, 25 times 1 is 25. Now you might want to do long division here, but really you know that 25 goes into 104 times. And then another 25 will be 125. And then another 25 will be 150. So 4, 5, 6 times. If you don't like that, then do the long division. But since you know it goes into 104 times, and then it's going to go into 50 another 2 times, then it goes a total of 6 times. So what this means is that if I have 50 turtles on my turtle farm and I'm going to give 12% of them away, I'm actually giving away 6 turtles. That's what I'm doing. All right? Now let's redo this. Notice we had some larger numbers. We had to think a little more because these gave us large numbers here. Let's recalculate it. 50 over 1 times 3, 25. I pick a pair of numbers. Can I simplify the 3 and the 1? Not really. I can't do anything with that. But I can pre-simplify or cross-cancel those. I can divide top and bottom both by 25. 25 divided by 25 is 1. 50 divided by 25 is 2. I picked a pair and I divided both of them by 25 and I wrote the new numbers down. So now all I have to do is I say, well, the only thing left is 2 times 3 on the top is 6. 1 times 1 is 1 on the bottom, and the answer is 6. And it gives me the same answer. And that's much simpler because I had to think about this division a lot more because they were larger numbers. But pre-simplifying was very easy, and then the numbers became very small. So that's why we did it that way. I want you to get in the habit of doing it that way because in a minute, that's how we're going to do all of them. Next problem. Let's take a look at what is 80% of 65, right? 80% of 65. There's 65 watermelons in the grocery store, and 80% of them are juicy and red, right? And the rest of them are rotten. So how many of these watermelons are actually juicy and red? If 80% of them are juicy, how many do we actually have juicy? So first, let's take this 80% and let's make it into a fraction. 80 out of 100, right? And I can simplify this by dividing by 10 and dividing also by 10. 80 divided by 10 is 8, and 100 divided by 10, sorry, is 10. And I also got a new fraction here that it can also be simplified. So what we will do is take the 8/10, try to make it even simpler. We'll divide this by 2 and by 2. 8 divided by 2 is 4, and 10 divided by 2 is 5. So I get a fraction of 4/5, right, of 4/5. Basically what happened here, I divided by 10, but I could have divided by 20 here to skip all this junk and get to the end. If I divided by 20, 80 divided by 20 is 4, 100 divided by 20 is 5. But that's okay, I do it in 2 steps sometimes. This is the fractional equivalent. So we need to multiply the 65 watermelons we have we're going to chop it down by multiplying by the fraction equivalent of this percent, 4/5. So what it's saying is if 80% of them are juicy and red, it means 4 out of every 5 of them are juicy and red. So we're going to multiply these, right? Like this. So you can see in this problem that this is going to be quite a bit of work here. If I take 65 and multiply by 4, I'm going to get a large number. And then 1 times 5 will be 5 over here. I'll get some number on the top and some number on the bottom, but I'll have a large number. 65 times 4, it's already getting hard to multiply these fractions because I'll have to do some side math over here, and then I'll have to divide them. It'll be a mess. But notice that I have a 65 on the top and a 5 on the bottom. I can just pick this pair of numbers and divide both of them by 5 ahead of time. 5 divided by 5 is 1. 65 divided by 5 actually turns out to be 13. And if you're not sure about that, if you think about 60 divided by 5 is 12, because 12 times 5 is 60. So 65 divided by 5 must be 13. And if you need to go off to the side and figure that out, that's fine too. So basically you're dividing this by 5 to get 1. You divide this by 5 to get 13. All right? Now, when we multiply 13 times 4, these are much smaller numbers. Even though we still have to go off to the side, everything's smaller. 3 times 4 is 12. This is 4, and this is 5. So you get over here on the top 52. But on the bottom, all you have is a 1 times 1, which is a 1. And so all you have is 52. So here, if we did it by doing a strong multiplication, we'd have to do larger numbers of multiplication. Then we would have to have a 5 on the bottom. We would have to do long division to figure out what the answer is. Here we pre-simplify. We had to do a little bit of thinking, but the numbers that we multiplied were all smaller, and then we didn't have anything at all on the bottom except a 1, so we didn't have to do any division. The answer here is 52 watermelons. So if I had 65 watermelons and 80% of them were juicy and red, it means 52 of them are the ones that are juicy and red. You're just going to have to trust me that cross-simplifying like that is going to help dramatically as we go forward. All right, for our next problem, I want you to pay close attention to it because there's something I really want to point out for you. 25% of 84. 25% of 84. So let's say I have 84 biscuits and I want to give 25% of them away to my mother, right? What does that mean? First, what is 25%? 25% means 25 out of 100. And I can simplify that fraction by dividing the top by 25 and dividing the bottom by 25. So the real fraction, or the simplified, 25 divided by 25 is 1. 100 divided by 25 is 4. So 25% is exactly the same thing as 1/4 of something. So I just start with the 84 biscuits that I have, and I'm going to multiply it by 1/4. That means I'm going to cut it down from its original amount down, multiplying by 1/4 of its original size. And of course, I can make that 84 over 1. All right. Now, at this point, we got to the point where if I multiply, I'm going to have 84 times 1, I'm going to get 84, and then I'm going to have 1 times 4 is 4, and I have to take 84 and divide by 4. There's nothing wrong with that, but I want to show you how to cross-cancel and cross-simplify, pre-simplify first, and really make it your primary way of doing things because it saves so much time. So what you can do is you can say, well, the 1 and the 1 are going to go away. The 4 and the 84. What can I do? I see that this 84 might be able to be divisible by 4, but I'm not sure because I don't know what 84 divided by 4 is. I'm not really a human calculator. Maybe I can get there, maybe I can't. But I know I can divide by 2. So I can divide 4 divided by 2 and get 2. And 84 divided by 2, if I cut this in half and cut this in half, divide by 2, I'm going to get 42. And that's pretty easy to do in my head because 84 8 divided by 4, cut it in half is this, and 4 cut it in half is this. So when I divide both by 2, I get this. But then I notice that 42 and 2 are also divisible by 2. So I can actually do the same process again. I can take this pair of numbers and say 2 divided by 2 is 1, and 42 divided by 2 is 21, because cut this in half and cut this in half, and I'll get 21. So what this actually means is if I had started with the 84 and the 4, I would have been able to divide by 4 and by 4, and I would have done it in one step. But if you don't notice that, just do it by 2 and do it by 2 again, and you'll get to the same place. So what do you have? 21 times 1 is going to give you 21. And of course, 1 times 1 is 1, and so you only get a 21 as an answer. And that's much easier than taking 84 and divide by 4 and doing the long division that you'll have to do. Yes, it looks a little ugly here with the pre-simplifying, but when you get down to the end of it, it's easier to do these simpler steps and then get the answer than to do a very large division at the end. So the answer is 21 biscuits I'm going to give away if I'm actually giving away 25% of them. All right, the next problem that we're going to do is, let's take a look at this. It's really important that you understand the concept here. 200% of 12. 200% of 12. Now you might say, wait a minute, 200%, that doesn't make sense, right? Because a percentage scale only goes to 100. So how can you have 200? Well, here's the thing that you need to remember. When you have 100%, you have kind of like all of what you're talking about. But if you have 200%, then you have 2 times whatever it is you were talking about. Right? When you think about it, because if you think about it, 50% of something is cutting it in half. 100% of something is taking everything. So 100% of 12 would just be 12. But 200% would be taking what you have and doubling it. Because you not only have just 100%, you have 2 times that. You have 200%. So if you ever see a percentage more than 100%, it just means you're going to end up with more than what you started with. 100% is all of what you start with. 200% is double what you started with. 300% is triple what you started with. 400% is quadruple what you started with, and so on. So 200%, if you want to do it rigorously, 200% means 200 out of 100, right? Because all percentages are out of 100, but 200 divided by 100 is just the number 2. So this is the fraction I'm multiplying by, right? But if I start with 12, which is what I have, 12 biscuits here, and I'm going to take 200% of them, I'm going to multiply by this fraction, but the fraction is really just a whole number of 2, so we can just make it 12 times 2, and that would mean that you would have 24 biscuits or whatever. So if I told a bakery, hey, I want you to make 200% of a dozen for me, 200% of 12, then they would know that they would need to make double their daily capacity or whatever, give you 24 biscuits. So it's double what you start with, because 200% works out to a fraction of 2 over 1, or just 2. So let's do a related problem. If that is what 200% looks like, then let's solve what does 150% of 12 look like. Well, if 200% means we take what we start with and we double it, because 100% is all of it, and 200% double that, what do you think 150% is? 150% would be like you have all of what you start with plus an additional 50%. Think about the word 100 and 50%. 150%, that's what it means. 100% plus an additional 50%. So it's 1.5 times, So if 200% is 2 times, and 300% is 3 times, and 400% is 4 times, and 100% is 1 times what you start with, then 150% is 1.5 times. Let's see how that works out with math. 150% means 150 out of 100. But we know from before that we can strike any zeros, we can cancel any trailing zeros, so really all we have is 15 divided by 10, or 15 tenths. And we can divide this by 5 and divide this by 5. So the fraction that we actually get from this is 15 divided by 5 is 3, and 10 divided by 5 is 2. 3 halves. And if you remember back to, I'll say or, remember back converting to mixed numbers. Well, I'm going to divide this in. It's going to go 1 whole time. 3 divided by 2 can go 1 whole time, with 3 minus 2 is a remainder of 1 out of 2. Look at that. It's 1.5. Didn't we just say that 300% was 3 times the amount of what we start with, and 200% was 2 times the amount we start with, and 100% was 1 times the amount we start with. So 150% means 100% plus another half, plus another 50%, 1.5 times. So if we take the 12 and we multiply by, you can multiply by this if you want, or by the 3 halves. This is what we're going to have, 12 times 3 halves. So we look at this, we have you can make it over 1. We have a 12 and a 2. We're going to divide both by 2. 2 divided by 2 is 1. 12 divided by 2 is 6. We just pick a pair of numbers, divide both by 2. Now what do we have? 6 times 3 on the top, 18. And then just a 1 times 1, 1 on the bottom, we have 18. And this is the final answer. So if a bakery is making a maximum of 12 biscuits a day, let's say, and we ask them, guys, I want you to work overtime. I want you to make 150% of your daily biscuit production, right? What they're going to do is say, all right, we're going to crank out 18 biscuits. Why? Because their daily production is a maximum of 12. That would be 100%. But we're going to push it into overdrive. We're going to go full throttle all the way to the max. We're going to make 150%, or alternatively 1.5 times what we can normally make, and we get 18. Because 1 time would be 12. Half of this is 6, right? So the 50% is half of this is 6. So 12 plus 6 is 18. That's another way to think about getting the same exact answer. All right, we only have one more problem. I need to find a place to squeeze it in. And I think I found the place right here. Here's our very last problem. Let's take a look at 60% of 8. If I have $8 and I'm going to give 60% of it away to my best friend, how much am I going to give away? Well, we're going to say 60% is 60 out of 100. But this is a fraction I can simplify. I can divide the top by 10, and I can divide the bottom by 10. 60 divided by 10 is 6, and 100 divided by 10 is 10. But then I say, wait a minute, I can divide this by 10 also. Or not by 10, I can simplify this as well. So I can divide this by 2 and this by 2, and 6 divided by 2 is 3, and 10 divided by 2 is 5. So it's 3/5. So 60% is 3/5, right, of 8. So if I have $8 and I'm giving 60% away, I'm going to start with $8 and I'm going to chop it by multiplying by 3/5. I can make this 8 over 1. So I try to cross cancel by say I have 8 and a 5. That's not really, I can't really divide anything to make it simpler. 3 and 1, I can't really make that any simpler. So in this case, I can't really pre-simplify anything. So I just multiply. 8 times 3 is 24, and 1 times 5 is 5. So look what we got here, an improper fraction, right? An improper fraction. So we need to convert that. How do we convert that improper fraction? Well, we divide it. So 24 divided by 5. So 8 times 5 is 40, that's too much. So 6 times 5 is 30, that's too much. 5 times 5 is 25, that's too much. It can only go 4 times. Why? Because 4 times 5 is 20. So it only goes 4 times. And the remainder, 24 divided by, minus 20 is 4. And then it has a 5 here. So converting it into mixed number, it goes 4 whole times with a remainder of 4 out of 5. So this is the final answer. You could write either one, but I think it's easier to read 4 and 4/5. So what it basically means is if I have, let's say, 8 pizzas. Let's think about pizzas instead. And I'm going to give away, let's just pretend it was 50% of my pizzas. If I was giving away 50% of my pizzas here, then it would be 4 pizzas exactly. But I'm not giving away 50%. I'm giving away more than that, a little bit more than that. So it's got to be more than 4 pizzas. 60% works out to be 4 whole pizzas plus almost another whole pizza. 5/5 would be another whole one. This is 4 and 4/5. So almost 5 whole pizzas. So the basic idea is we use percentages to talk about what's happening whenever we, there's lots of uses for percentages. We give a percentage of our money away to somebody. When we have a budget, a monthly budget, we talk about how much money we make every month. You might have a budget where you say, okay, 20% of my money goes to groceries, and 10% goes to electricity, and 10% goes to something else, and 5% goes to savings or whatever. And when we talk about percentages, we just pretend that all of what we're talking about is out of 100. So we don't care about the actual number of dollars we make every month. because that gets cumbersome. We talk about a percentage so we can break it up into a maximum of 100 and talk about how much goes here and how much goes here, all as if it were out of 100. And when we calculate that we're giving away a certain percentage of something, or we're saving a certain percentage of something, then what we do is we have to take the number and we have to chop it by multiplying by the percent. But we never ever multiply by 20% or 30% or 40%. We don't. We always multiply by the fraction equivalent in this lesson. In future lessons, we can also multiply by the decimal equivalent, but we never multiply by 20 or 30 or 40. We always multiply by the fraction or the decimal equivalent. I'd like you to practice all of these problems. They're very, very important. And then follow me on to the next lesson. We'll continue building skills with calculating percents using fractions.